Take a look at this line here, which passes through the points 0, 1 and 3, -1. You can write the equation for this line as y equals what? Right, the equation for a line is y equals mx plus b, where m represents the slope and b is the y-intercept. So can you figure out this line's slope and y-intercept based on the graph over here? Then plug those numbers back into your expression. Exactly, the slope of this line is -2/3 and the y-intercept is 1. So the equation for this line in slope-intercept form is y equals -2/3 x plus 1. Next, take a look at this line, which passes through -3, 1 and 2, 3. What's the equation for this line? This is trickier because you're not told what the y-intercept is for this line. Let's figure this out together using an interactive graph. So here's an interactive graph where you can draw your own line. You can change the slope by dragging the line up and down, and you can change the y-intercept by dragging this yellow dot. So try making a line that passes through -3, 1, so that's this point over here, and 2, 3, which is this point over here. Exactly, so the line that passes through -3, 1 and 2, 3 is y equals 0.4x plus 2.2. Using slope-intercept form, finding this equation was tough. Let's see if there's a better way to determine the line that passes through two specific points. Okay, suppose you want to find the equation for this line, which passes through the points -3, -2 and 2, 1. First off, what's the slope of this line? Precisely, the slope is 3/5. Now let's say we have another point on this line, whose coordinates we'll call x, y. Now if you were to measure the slope of the line between these 2 points, you should still get 3/5. So the difference between these y-coordinates, y minus 1, divided by the difference between these x-coordinates, x minus 2, this expression should still equal 3/5. Now let's take this equation and multiply both sides by x minus 2. So on the left side, the x minus 2 terms cancel out. That leaves us with y minus 1 on the left, and that equals 3/5 times x minus 2. And it turns out this is a correct equation for the line. For a point to be on this line, its x and y coordinates must satisfy this equation. Now where did these numbers come from? Well, 3/5 is the slope of the line, 2 is the x-coordinate of the point our line passes through, and 1 is the y-coordinate of the point. In general, for a line with slope m that passes through a point with coordinates x1, y1, you can plug in m for the slope in this equation, x1 for the x-coordinate, and y1 for the y-coordinate. So the equation for the line is y minus y1 equals m times x minus x1, where the x minus x1 is in parentheses. And this is known as point-slope form, because looking at this equation, you can read off a line's slope and a point the line passes through. Let's put this formula to work. Suppose you have a line that passes through the points 1, 3 and 7, 5. To find an equation for this line, you can calculate its slope and use the fact that the line passes through 1, 3. So a point-slope equation for this line is y minus 3, because 3 is this point's y-coordinate, equals what? What goes on this side of the equation? Excellent! The slope is 2/6, which simplifies to the fraction 1/3, and you're multiplying that by x minus the x-coordinate of this point, which is 1. So this is an equation for the line passing through the points 1, 3 and 7, 5. But hold on a second. Why did we plug these coordinates into our equation? Couldn't we have plugged in these coordinates for x1 and y1? Then the left side of our equation would be y minus 5. And what's the right side for this new equation? Exactly, the slope is still 1/3, and the x-coordinate of this point is 7. So another point-slope equation for our line is y minus 5 equals 1/3 times x minus 7. So we found two equations for this line passing through 1, 3 and 7, 5. That's concerning since only one line should pass through both of these points. Well, what happens if we take these two equations and rewrite them in slope-intercept form? In other words, solve each of these equations for y in terms of x and write them so that y equals some number times x plus another number. Try doing this with the top equation first. Exactly, so this first equation can be rewritten as y equals 1/3 x plus 8/3. So the slope is 1/3 and the y-intercept is 8/3. Now try doing the same thing for this second equation, rewriting it in slope-intercept form. Exactly, this second equation can also be rewritten as y equals 1/3 x plus 8/3. So they may look different, but these equations are actually the same line. The same values of x and y solve both of these equations. So when you're given 2 points that a line passes through, first calculate the slope, and then you can plug either of the 2 points' coordinates into the equation. Next, suppose you want the equation for the line passing through the points -2, 1 and 2, -5. Let's plug these coordinates into our point-slope formula. So the left side is y minus 1. What's the right side of this equation for the line? Nicely done. So the slope is -6/4, which simplifies to -3/2. Now the x-coordinate of this point is -2. So inside the parentheses here, we have x minus -2. Subtracting a negative is the same as adding a positive, so we can write this as x plus 2. And here's the point-slope equation for the line passing through -2, 1 and 2, -5. We could also have used this point in the formula. So the left side is y plus 5, because that's y minus -5. And the right side is -3/2 times x minus 2. These two equations are equivalent. They're both correct equations for the line. So remember that these are minus signs in the point-slope formula. And when you have negative coordinates, like over here and here, you'll get plus signs in your equation. Next, try taking this point-slope equation and rewrite it in slope-intercept form. So y equals some number times x plus another number. And keep in mind that this number over here, the y-intercept, might be negative. Excellent! Let's see that graphically. So here's the point-slope equation you started with. Y minus 1 equals -3/2, or -1.5, times x plus 2. In other words, this is a line passing through the point -2, 1 with a slope of -1.5. In this interactive, this button here will switch us from point-slope form to slope-intercept form. So let's go ahead and push this button. Sure enough, this is the exact same line, but now it's in slope-intercept form. The slope is still -1.5 and the y-intercept is -2. So the slope-intercept form is y equals -1.5x minus 2. Let's finish this lesson with some interactive questions. Suppose you were asked to plot the line y minus 1 equals 2 times x minus 3. Now, you could graph this line by converting the equation to slope-intercept form and then moving this point to the y-intercept and setting the slope. But there's a faster way. Notice that this equation is in point-slope form. Y minus a y-coordinate equals the slope times x minus an x-coordinate. That means this line passes through a point with an x-coordinate of 3 and a y-coordinate of 1. So let's move the yellow dot over to 3, 1 here. And the slope is 2, right? So set the slope equal to 2, and then you'll have the graph for this equation. Nicely done. Next, try plotting the graph for y plus 2 equals negative 1/2 times x minus 1. Again, notice this equation is in point-slope form. So first, use this equation to find a point the line passes through, and then set the slope. Right, so this equation passes through the point 1, negative 2 and has a slope of negative 0.5. This was a very challenging lesson, so nicely done.